it didn't kick me out. So now we are good. So we are on recording. So thank you, Khautan, for explaining me that why there are not so many students I can see. Okay. So that's we have done. Yeah, that's we have done. So don't forget to solve these at home, okay? I have done the first one, so you can do the rest one. Solve it properly at home. Now, what is Chebyshev's theorem? As you see different shapes in front of you, empirical rule is only used for symmetric. But how do we know about these kind of shapes, that what kind of distribution? And if somebody asks me for non-symmetrical shape, that how much range, how this score means a student having like 85 score out of 100, where does he fall in the distribution? So how do I know, regardless of shape? So it is used on any kind of shape other than symmetrical. So at least we can say that here at least 1 minus 1 by k square must lie in k. What is k? We will see. So there we were using 1 standard deviation, 2 standard deviation, and 3 standard deviation, right? So here we see k standard deviation or k sigma. So we will have formula of mu plus minus k sigma, right? The portion of any data set lying within k standard deviation and k must be greater than 1 of the mean is at least. What does this mean? So if I take you back to the camera, to the whiteboard, just like this, and make it bigger. Now I think you can understand it clearly. So we say, look, in symmetrical we were having mu plus minus sigma, or 1 standard deviation plus minus 2 standard deviation, that's in symmetric, and that's 3 standard deviation or sigma. Here we say the data must lie under mu plus minus k standard deviation. And what is this k percentage? We can get it this percentage from 1 minus 1 by k square. So this percentage must lie under k standard deviation. Do you understand? Just like we were saying that 68% must lie there, so 95% must lie here, and 99.7% data must lie here in symmetrical. So here we don't know exactly the shape, so we can use this 1 minus 1 by k square percentage must lie in k standard deviation, plus minus k standard deviation. Understand? And k should be greater than 1, because if k is 0 or less than 1, it gives us the numbers which are not suitable with the mean or average. So if, let's say, if k is 2, yeah, if k is 2, what will be the dispersion? So it can give us mu. It will give us the range mu plus minus 2 sigma. And in this case, mu plus minus 2 sigma, 95% data lies. But here, how much percentage data lies? We can see this is the percentage. So 1 minus 1 by 2 square. And it's like 1 minus 1 by 4, which is 3 by 4, which is 75%. So in this shape, It is a shape where 75% data lies here. So you see, for sure, it's not symmetric because in symmetry it's 95%. So how do we know that? Is it like skewed, then positive skewed or negative skewed? And if you do it at home for k is 3, because we just hear like 1, 2, 3. So for k is 3, first take out the mu plus minus 3 sigma. So how much data? Instead of 2 is 3, 3 square 9, 1 by 9, then 9 minus 1, 8, 8 by 9, something, right? 8 by 9. So 8 by 9, and what do you get from 8 by 9? 0 0.0. So 9, 8, 9 times 8, how much? Wow, I forgot. 9 times 9, 81. 9 times 9, 81. That's I know. So 9 times 8, 72. So here it comes again 8 and then 0. So it's 8, 8, something 8, 8. And 8, 8, 8, 8, 8, 8, 8, 8, 8, 8, 8, 8, right? So it can I write this 88.9%? Yes, I can write. So see, that's the difference. So this shape is a bit skewed. Let's have a look. So if this is lesser, it's going to write. This is more, it's going to. If you have like k is 4 and 5 and so on. So let's see with the example. So now let me take, oh, sorry. I'm sorry to myself because I just dropped something. Anyway, so now so in any data set, at least this one, so we understand this. So we have calculated all these things, right? So there is no issue. You understood. Now let's take an example. The mean time in a woman's 400-meter dash is 52.4. So this is mu, that we know, with a standard deviation of 2.2 seconds. So this is sigma. At least 70% of the women times will fall between what two values? So they are asking us about finding the range. So can you guess? 75%. We know 75%. We have calculated. So 75% lies in, because it's not symmetric, so 75% lies among mu plus minus 2 sigma. So just put the values, 52.4 plus minus 2 and 2.2. You are accountant, so you can quickly solve it, right? So this is the range we can have. So this is mu. This is every step, like 1 standard deviation, 2 standard deviation, 3 standard deviation, 4 standard deviation, right? So these are the times. So 2 standard deviation is between 48 and 56.2. So this is the range. So at least 75% of the women's 400-meter dash times will fall between 48 and 56. Easy, right? It's super easy if you know the formulas and if you understand the formulas. Now let's see another example. The mean price of the house in a certain neighborhood is, this is mu, and the standard deviation is sigma. You just need to allocate that what is what. Find the price range. Again, it's asking for at least 75%. So again, it's the same thing. You can apply Chebyshev theorem, states that 75% of the data value fall within 2 standard deviation, which means between this. So this is the answer, right? Easy. There is another example. You have the slides. Do it by yourself. and let me know if you find another example. I'm gonna share one example like this one. Uh, just like have a quick review. A survey of a local companies found that the mean, again, mean is this one. Standard deviation is this one. Using Chebyshev theorem, find, okay, this one is a bit different. Now, he already have given us the range. So he's asking that how much percentage fall under this range. So we substitute the value of the mean and we can get the k. So we know this is mu, this is plus minus k standard deviation. We know this. Okay, so you can also get from here, this is plus k standard deviation, or you can also get it from there, minus k 0.25. Oh, sorry, 0.2. So it's 0.2 equals, so the lower range is 0.30. So you can solve it from for k and you can get the k and from upper. So that's why it's mu plus minus k sigma. Okay, so you can get it from both ways. Once you have done, you can get k 2.5. You can put the percentage into the percentage. We already know. So this one is really important. Once 1 upon k square. And you can get 84% answer. So 84% of the data values will fall between 0.30 and this. Now let's consider the z-score. It is really important. Z-score is really important. What is z-score? I think I should tell you on the board. It's okay, Haotian, don't worry. It's okay. I was just wondering why they are. So at that time. So now there is no problem. So it's okay. It's fine. So let's talk about the z-score, because this z is you gonna use a lot in statistics, and not only in this class, not only in this course, but also other courses. Um, so we call it z-score, and we can also call it standard score. So that's the standard score. So what is the standard score in a distribution of a data set? Uh, got it? This is very important concept actually. You are going to, as I told you, you are going to use a lot in further classes and your also other courses. Not maybe pure accounting courses, but relevant to the CFA, and if you're preparing for financial accounting or accounting management or CA, these kind of certification as well. If you will be confused in understanding this, you can ask me again and again. But first, try to understand this, and because this is really important, I'm again putting a much more focus on z-score. Let's see how to calculate z-score. First, let's see the formula, which is given as z is a value, any value, minus mean by standard deviation. Or any value, because if we have x, we have x1, x2, x3, and so on, xn. and we have x bar given, which is sum of x by n in this case, because there are n, right? Because we can calculate x bar from here, and x is the value x1, x2, x3. And of course, once we get x bar, you can also get x minus x bar, and you can also get x minus x bar square. You have done this, right? And you can also get sigma square, sum of x minus x bar square, x bar, sum of x by n upon n, and sigma is underscore sum of x minus x bar square upon n. So from here you can get sigma, you can get x bar. So you have x bar, you have standard deviation, so you can calculate z. This is difficult one because nobody have time to calculate these columns. So what we do, we can do simply in Excel. How we will see in example after this concept, I will tell you in Excel. So we have to calculate z score in Excel and see what does that mean. But let's see what does it interpret. So can I write this thing in this way? X minus mu, because x bar is also mu upon sigma. So that's the z score. So if we are given x series, it can be any stock, it can be any asset, then it's easy to find the mu and variance. You can get z. Here we need to know that what does this z means? What is the interpretation? So let's see the interpretation of z. If I'm all right, what is the interpretation? How, what can somebody extract from this, that what is z? It's really simple. It shows the number of standard deviation. So z shows how many times the standard deviation, that's number. How many times means number of standard deviation, my data point, which is x, lying away from mean, which is mu value. Do you understand this? So z tells us that how many times standard deviation, my point, which is x, x1 here in this case x, is lying away from mu. How? You can just simply say that if I take sigma there, so x minus mu is equal to z sigma, right? So what is x minus mu? My data points away, this is the difference, right? So my data point away from the mean value is equal to how many times of sigma. So this is the z is showing the times, the number, right? Number of standard deviation. Do you understand? You can further solve it by taking mu plus minus z. So if I take it here, just so that you can see it clearly. So can I say mu plus z sigma equal to x? So here I can also extract. So you can say, so if z is positive, if this score is positive, then it's positively skewed. If it is negative, then it's on the left side. So that's the interpretation. Okay. Do you understand this concept of z score? Now we will see with an example. It's easy. So what I'm gonna do, I'm gonna share the screen, and I will back where we have left. Okay. So we know this. Now, if I ask you the test score for all statistics final students at the Union College, and let's take our example at in our class, have a mean. So this is mean mu. We know that standard deviation sigma is given. We know that. Find the z-score for the test score 85. So this is x. So you can easily find z, right? So z will be x minus mu upon sigma, which is this, which is 1. Now, what does this mean? This means that 85, a student who got 85, if it's like Hautian, so Hautian got 85. So this score is one standard deviation, 1 point away from the mean value of the total class score. So it means the total average of the class is 84. We can find out. So this is one standard deviation higher than the, sorry, it's like 1 time standard deviation minus 85. That's the mean. Similarly, you can draw this, that how many people are less than 70 or what test score falls under 78. See, so for 70, now this 70 is less than mean, so it gives us negative sign. So this means this score is 1.14 points, standard deviation points less than the average of the class. And this means when it's equal, so it means it's 0, means their score is the same as the mean. So do you understand this? Z-score. Or we can have like a couple of example represent the number of standard deviation that data value x falls from the mean. I've already told you, so we have done this, right? Okay, it's repeated. Now let's take example of Romeo and Juliet. I just made up of this example. So let's say Romeo and Juliet are in two different classes, right, of statistics. I'm teaching two sessions of statistics, right? So let's say Romeo is in your class and Juliet is in another class. So Romeo received 75 score on a test whose class mean is 73.2, right? With the standard deviation of 4.5. Now solve it by yourself right now within few seconds, because now you know Juliet is in another class, statistics class 2, and she got 68.6 on a test score whose mean is 65 and standard deviation is 3.2, 3.9. Which student had better score, Romeo or Juliet? Tell me. I give you 2 minutes to solve this. Yeah, I give you 2 minutes. So now it's 26 past 9. So tell me before 28 past 9. Oops. Quickly solve this. It's really simple. It's easy. Who is the better student, Romeo or Juliet? Oh, we got the answer. So Juliet long is right. Long Lynn is right. Yeah, that's right, Juliet. Let's see how. So we got the winner, right? So Ling is genius in the class, right? I hope that Lynn is not the outlier. There are other students who can answer in the same way. So let's say Romeo's, we have first need to calculate the Romeo's z-score and Juliet's z-score. So we know the formula for Romeo. We just put in this and we get the z-score, which is 0.4. Now we do the same for the Juliet, and which is 0.92. So you see the Juliet class is on average is not better than Romeo's, but that's why Juliet's score is better. So Romeo's score was 0.4 standard deviation higher than the mean, while Juliet's score was 0.92 standard deviation higher than the mean. So Juliet's test score was better than Romeo's. So that's the, I'm sure you didn't see the slides, right? Which I have given you, Lynn. So that's how you can solve it. So you have a couple of examples here. You can do it by yourself at home. You can practice and you can try to find out which one is better in what. So this is another example of a French language, consists of grammar and vocabulary. And you can find out. So you just need to note one thing. At first glance, it seems that student one has scored better in grammar, because we can see 80, right, and 66, and vocabulary as then vocabulary. But what actually you need to take the z-score of all the students and see. So this student actually have done better in vocabulary, not in grammar, because the z-score of vocabulary is higher than the z-score of grammar. And this student has done better in the grammar, and this student has done better in the grammar as well. So that's how we do this. Just have a look. We already have known coefficient of variance. We have done this in important point in like finding the spread. You know that coefficient of variance is sigma upon mu, x bar upon 100. We have learned this. So if you have two sets, so you can find out that which one is better as well. So measurement of relative dispersion. Now, how to measure the shape of distribution? This is really important. So first, let's go to the whiteboard. Then we will come here again. Okay. So we know that if we have two distribution, we can get coefficient of variance of respective series and can tell which one is better off. Now, how to measure the shape? Shape of the distribution. That's we just skipped like kurtosis and skewness. So first, let's talk about the skewness. So just like measure of variance is can be extracted with the coefficient of variance, which has this formula upon sigma times 100. So if the is this positive skewed or negative skewed or symmetric, we can measure these shape with the coefficient of skewness. That how much skew the distribution is, and it's shown by SK, and it's given as 3 times mu minus median by sigma. Why? Let me tell you. If symmetric positive or negative skewed, so we need to find the coefficient of skewness. This means comparison, the distance between one distribution and another distribution, comparison between or comparison of mean and median with, if I give the words, ratio to the error. What is the error? Standard deviation. Here it's just mu. So that's give us the measure of dispersion. Here we need to see that the difference between one average then another average. So skew in symmetrical shape, Sk is 0. Why? It's obvious. In symmetrics they are equal, so this will give us 0 on the upper side, and this total Sk is 0. But if Sk is less than 0, then it's negative skewed, and if it's greater than 0, then it's positive skewed. We can say that in symmetric, mean is equal to median. But here in positive skewed, mean is greater than median, right? So here mean is greater than median, is greater than mode. This we know. And here it's less than. See, so that's how we can calculate So you can see that's how we can calculate the coefficient of skewness. That's the basic definition. That's the formula for it. So here the mean is equal to median. Median in here is uniform and symmetric. In both cases, mean is equal to median. Because uniform is the same number, so of course median is the same repeated number, and mean is also the same average. And in symmetric is also it's same. So remember, in symmetrical distribution and uniform distribution, these two averages are equal. Whereas in skewed and right skewed, means positive skewed, mean is greater than median and greater than mode, and in left or negative skewed, it's less than, mean is less than median and less than mode. So that's how we measure the shape of the distribution through coefficient of skewness. Understand? So let's start with Excel in last 20 minutes. And then in next class, we will go through the book chapter 3 and 4, 2, 3, and 4, and we will see how many concepts we have covered. So at the moment, just open. So let's take example, and let's take some, note down some mathematical Excel formulas. I'm gonna go for Yahoo. Oh, where's the charger? I need to charge my laptop. So far you understand everything, right? So you just need to go to bing.com and just use Yahoo Finance and tell me any company name. H&M. H&M is a cloth company, and then you will click, and you can get this kind of a data sheet with the historical data as well. So I'm just taking the stock data of H&M. H&M is like a clothing company. You must be knowing that. So let's take yearly or monthly. Okay, there's no yearly, so let's take monthly data from 2014 up till now. Apply. Once you're done, yes, it's done. So then you just download the data. Go. What I don't need anything else. I just need the prices, which is this one. So let's say this is our X, which is H&M stock price, stock closing price, adjusted price. Right, so these are the data points. You just copy it, Control C, Control V. So these are the data points over the time. So we can have that time. What is the time? The date is given. So I'm just gonna copy the same date. It's a monthly date. So every month. So these are different data points. Now, what is the distribution? You can draw the distribution now. How? But let's first see the stock on the 16th January, where the data lies. So we need to calculate some basic formula. That's mean, standard deviation. But before standard deviation, we can variance, standard deviation. These three things are really important to know. Once you know this, then it's really easy for you. What is mean? You can use average. I told you there are two ways. First, this is X, so you need to use X minus X bar. So X bar equal to, what is X bar? X bar is sum of all the values of X divided by total number. Which is, in this case, maybe something like, let me see, 22, 74, 72. So here N is 74, but I'm not going to use all these. So what I'm going to use the simple Excel formula. So there are inbuilt formulas for Excel. Look, what does it mean? Equal average. That's it. So you write average and then you select it, and then you can drag down until 72, 74, and then enter. So that's the average stock price of this stock over last 6 years. So you see that's a dispersion. Let's take it in a one single form. So you see in 2014 there was like a big distraction, big deviation from the mean. Mean is 190, but in 2014 it was like 200. The point was 233 with this on this date. So what is the variance? you can choose in different way. I'm just going to use the definition of the formula, which is VARP, and then what is VARP? You can also know it. So if you see, when I write VARP, it calculates the variance based on the entire population. Ignore the logical values and text in the population. So it only takes the entire value. Okay, that's why I'm taking VAR. Whereas VAR calculate the variance based on sample. So I'm here, this is my whole population. That's why I'm taking the variance of the population. Okay, and that's when I select it and I put enter, it gives me the variance. So now this is the variance, the sigma square. Oops. So I can take the square root SQRT, that's the square root of a number, which is this one, and enter. And I can also find standard deviation by using the formula STDEVP, population, remember, and select the same, enter. So that's the standard deviation, that's the sigma. Now we have all the information we need, so we can calculate different things. Well, what is the coefficient of variance now? Coefficient of variance. Coefficient of variance is mu by sigma. So mu is mean by sigma is standard deviation, and it's time 100. Or we can just take it in a percentage. So this is the coefficient of variance. So if I put it percentage, so it's the coefficient of variance is 374%. So in this talk, there is a huge variation, right? That's we have learned. Now let's see if the distribution is positive skewed or negative skewed, right? So we need to get the value of skewed. So we just remember the formula, right? What is the formula? Equal to bracket 3. First we need to get out, we also need to find the median. Yeah, I think there will be no median. Let's see. A median of, you just put the formula and you can get the median. So okay, we got the median as 183. So it means it's not symmetrical. That's for sure, because mean is not equal to median. So now you can get the skewness formula. You already have the formula, and which is 3 times what? 3 times mu minus median. So mu minus median. And divided by standard deviation. So that gives us 40%. So there is a 40% plus 40% coefficient of variance. So it means it's positively skewed. So it's shaped like this, like positive skew. You know the shape of the positive skewed. So now calculate the z-score of z-score on, let's say, Haotian, what's your month of okay, let's say any date, random date. Let's say March 2018. So where does it fall? So what is z? You already know z is x minus mu, which in this case March 2018. March 2018. This is the x value of March 2018 minus average minus mu divided by standard deviation. right? This one. So it's minus, z is minus. So the score is minus 1.56. So that stock score is minus 1.56. So that's how we can calculate about different distribution. You can also further show different values. You can ask your classmate about different question and then ask her or him to calculate these things for you. So do you understand this one? So what I'm gonna do, I'm gonna save this one, and I will also send this with the formula to you. So now you know how to get the data, right, from any source. I just used one Yahoo source with you, and this Excel file I will also share with you now, right now. So you can practice, you can download different stock, more than one, and then you can find out the coefficient of variance and see which one is better to invest. Um, so now we have covered almost all the topic, and next after the holidays we're gonna start about the probability. So we will learn about the basic probabilities and these concepts. Now I want you